keynote speaker is an industry specialist who will be discussing the biggest challenges customers are facing. Let's welcome Infrastructure Sales Engineer for Lenovo, Alexander Doherty.
Cool. Hey everyone, good morning. Welcome to QBITS. Excited to be here. A couple months ago they said, hey Alex, go talk about whatever you want. You're doing the keynote. I didn't know it was like the keynote, first thing in the morning. Set the stage. Luckily, that's already been done by Steve. As I was listening, I think I pretty much have the exact same content, but I threw it in ChatGPT and said, make it about motorcycles instead. So that's what you're going to get a lot of today. I'm not sure if anyone saw outside, we do have a Ducati bike. I don't know if it's like a real race bike. I think they just put the stickers on it, but it's pretty cool, and that's part of our Ducati sponsorship in MotoGP. They've won the last couple of years. What was that?
It is real.
It is. I know it's a real bike, but I don't know if it's not the one with like all the racing stuff.
It is a real racing bike.
Well then, I stand corrected. Cool. The reason I like having it up here is because one, it's cool to look at. They're fun. The people that go to IT shows and are interested in fast motorcycles is pretty much a solid circle on a Venn diagram. So always a fun to start with. But what I think it really speaks to is we just finished off with this collaboration. To win a race, to win MotoGP, to travel around the world and win most of the races, or at least get the most points, it's not just the fastest bike. It's not the best driver. It's the entire team. It's how fast your pit changes. The people doing the tire compounds, making the brakes run hotter, making the engines run hotter, making that Ducati engine go 500 more RPM than their competitors to win races. It takes an entire team to win a solution. And the difference between first place, the winning solution, and absolute last place, the one that no one buys, is about 1 second per lap. So it's extremely tight competition. It is breakneck speed. There's a ton of people working on it. It's the pit crew, which the engineers, the aerodynamicists, the chemists, the drivers, and of course the sponsors of the races. So that's kind of the main, the idea of the presentation is working together, and this one is around decrypting the edge. So that's one set of technology, and we'll get into what the edge is. I'm here to decrypt it. Call me the crypt keeper, I suppose. If this had been a Halloween, I would have done the whole costume, but wrong time of year. So with that said, here is the quick agenda for today. The first one is the intro. What's up? What are we doing here? And of course, what am I doing here as a representative, or I suppose an agent of Lenovo? So, I think we paid a lot to be here. So I gotta talk about Lenovo a bit, but that's the whole point. It's not just a big sales pitch. I promise I will say like 3 product names the whole time. Next, we're gonna look at industrial revolutions. And this was also just talked about. And we're gonna do kind of a brief history going from, agrarian society, mules up to trains, through cars, through AI, etc. And, kind of how we got here. And that's a bit of a history of enterprise IT, specifically as it applies to the edge. And I promise I will define that in a few seconds. And then we'll look at living on the edge. Some of the things we were doing in real life. These are not just art of the possible examples, because we could do those all day, and I do believe I have a session later on today, speaking of art of the possible, where we can look at general technologies and how we can tune those for your industry, for your company, to solve your problems, which is really what all technology is for. It's not just to make computers go faster or make a motorcycle go around a track quicker. It's to solve real-world problems, which ultimately lead to a better, higher standard of living for everyone. We'll look at making it work. Again, very specific examples, and some of the aspects of the technology which differ from kind of standard IT or personal computing or data center computing. Edge is really a new region of study which kind of encompasses all the traditional aspects. It is not client, it is not server, it is not cloud, it's kind of everything all at once. And then I have to do a summary because that's best practice with these things. So real quick, industrial revolutions. There's been 3 of them so far, and we're living in the middle of the 4th one. We mentioned, the acceleration of technology and how it's in our everyday lives. I can't imagine driving anywhere with a Google Maps up, giving me the best route. I honestly can't imagine doing anything at work anymore without some sort of AI augmentation to consolidate my notes. When we're on a meeting on Teams now with Copilot, it's incredible how nice it is to have very nicely typed out minutes sent immediately afterwards. The transcription, how we can summarize meetings. Almost everything I do now, I throw into ChatGPT, even for spell check. As I am based in Montreal, I do cover some French language business. je me trouve assez bilingue, but man, those out codes on the keyboard, I can't use the French keyboard, so throw it all in ChatGPT, it figures it out. Look, these things are real, they are everywhere, they are solving challenges. And we're in the middle of the fourth industrial revolution as we speak. The third one, not sure when it ended, but now we're in number 4. We're calling it digital transformation. It's the AI of everything, this making everything smart. But the big aspects of it, kind of the key defining parts are the integration of systems. It is making things work together. It is breaking down the silos between different workloads, between different aspects of a business or our personal lives, and integrating them to make all the data shareable, usable, as well as on more standard unified systems. Artificial intelligence. I think tomorrow's presentation this afternoon is Decrypting AI, and as we are now officially in the AI period of corporate events, I won't go on to it too much. I think we all know what it does, and I'm here to talk about edge. And of course, edge computing, often referred to as IoT or industrial computing. And it's been around for a very long time, but we want to look at how it is now becoming mainstream, ready to go, and available now through QuadBridge, of course. So yes, ultimately, in many of these cases, we are replacing people with machines. And we say, that's awful, we don't want to lose our jobs. But, I mean, no one mourns the horse people downtown, or the people that had to shovel the horse bits, or the icebox folks. You know, it's just, it's a thing. It's happening right now. Many of us could be impacted, but generally speaking, every single one of these industrial revolutions leads to a higher standard of living. Medicine, refrigeration, the ability to keep food, so you're not constantly going to get it. It revolutionizes the way we live. And so every industrial revolution, every major leap forward transforms our world, and generally speaking, for the better. Yes, it makes things like nuclear weapons, but it also means ambulances that can drive off-road to help people. It means vaccinations. It means cancer treatments. It means pretty much everything that we know and love and now somewhat take for granted that leads to the modern world. It's getting better. And ultimately, technology, at its core, it elevates human potential. It makes us, as a species, as a people, as a living organism on this planet, better. We can do more, we can live longer, we can be happier, we can be healthier, we can express ourselves more, and that's what technology does. So, high-level industrial revolutions, generally speaking, are good things. But now, we're going to talk about edge computing, and what is that? At its core, edge computing is acting on data physically close to where it's generated. Long-winded statement, but what that means is, when you're generating data, be it through a sensor, through a camera, through the people counting, walking through the door, this may be recorded right now, all of this data has to be stored and processed and analyzed for an outcome. We collect data to generate outcomes. We collect it at CERN, particle physics, to solve the greatest challenges to solve science, right? And to get together and work on those. And if we have to store this, move it around, analyze it, there's a lot of cost, complexity in doing that. And if we can act on more data close to where it is generated without the need to store it, for instance, a security camera, store those 4K video feeds, store them locally, ship them off to the cloud, way over here. This costs money. Everything I'm doing costs money, right? So we're storing it, we're processing it. Great, I'm in a data center now. I got to cool it, I got an expensive GPU. Cool, I see it. Oh, there's something on the conveyor belt. Alert the operator. Cool. I'm going to go back to my site, crappy connectivity in the middle of nowhere, and be like, hey, there's something on the conveyor belt, you should turn it off. You don't want to have all those delays and all that complexity and all the costs. So what you do is, you put that processing power at the edge. And that edge could be in the facility, in the local data center, or more often than not, it is a machine that's capable of processing the video feeds close to the machine physically. And those are not necessarily cooled data centers. They could be insecure facilities. They could have a high temperature. They could have shock, vibration, dust, whatever it may be. So edge computing is the ability to do processing power close to where data is made and you actually want to act on it. Self-driving cars are a great example. You don't want to have all those cameras and sensors on your car to amalgamate it. Send it over cellular to the cloud to tell you there's someone in the way. If you're going 120 kilometers an hour, that can't happen. So all that processing power has to be within the vehicle. And it's applying those same principles into the industries we all work in, be that retail, manufacturing, healthcare, etc. And we'll look at a kind of cool examples afterwards. So generally speaking, it is putting data center level performance in places not previously possible. I mentioned some of those. Could be an igloo, could be a vehicle, could be a sauna, could be a steel smelting facility. We're looking to put them in places that are rugged, that are tough, that are strong, that are handsome, which is why I actually have a real server in the back of my pants right now. If anyone didn't see me walk around kind of awkwardly. I don't have a back injury. It's not related to when I took the motorcycle up before I got here. Nothing like that. This is a real server. Right? It's got an NVIDIA T4 GPU. It's got 100 gig networking. It's got a bunch of rated, redundant power supplies, local storage, but it's also got Wi-Fi and cellular. It's a real server, but this thing can take a punch. It can run up to 55 degrees Celsius or 135 Fahrenheit for American friends here. So we're miniaturizing these. And this is a Lenovo, it's an ST350. I think I get 2 more product names the whole time. But point being, we sell this like any other device. You know, this is the server. You can quad-bridge your e-store. You can buy one of these right now. It's nothing special. This was before the realm of specialized manufacturers. This was the Siemens of the world, the ABBs, companies that made industrial-grade computers, which at their core are x86-based servers or desktops. But we're bringing it to the mainstream. Edge computing is here, it's real, and we want to put it everywhere, and Quad-Bridge can help with that. So I'm going to put this thing down, because I was recently at our big Edge conference down south, where they were teaching us how to pitch this stuff, and they said, it's like real estate. Edge computing is all about location, location, location. So if someone asks, you can tell them that. And ultimately, we're doing is we're using technology to solve problems that could be solved by people. Researchers could get together every week and compare notes. They could do that, but it's expensive to get there, and it's time-consuming, and quite often they don't speak the same language, and you have to translate it, and maybe there's interpersonal conflicts, who knows? It's pain. But if you can use technology to solve it, that's really where we're going with AI and Edge. One great example is in research. Again, it's on rare diseases. There are some diseases that only a few thousand people in the world have, and they could be crippling, debilitating, awful things, but there are so few people that have them, the research is very isolated. But now with AI, we can have doctors work together by sharing their notes and automatically translating them and summarizing them, and then also using high-performance computing to simulate the molecules in the human genome to solve these diseases and prevent them or identify how they happen so we can present it or create treatments for them. A lot of cool stuff is going on, and it's all about solving problems. Sure, I want to sell a faster, smaller, cooler-looking server, but at the end of the day, it's all about solving those problems. And we've been at this for a very long time, actually. We think of AI as being something brand new and exciting, and it is, but it's been around for a while now. The first chatbot, called Eliza, was to simulate human speech, and it was kind of like a therapist. It just asked you, how do you feel about that? Tell me more about X, Y, Z thing. And they could identify verbs and nouns and proper names, so you could have a conversation with it. And I think one of the first ones that passed some early version of the Turing test, but it's a chatbot. So we're looking at 60 years now. The whole product was like 64 kilobytes or something like that. I believe it was on tape or punch cards. Nothing new. 1997, I remember I was a kid when this happened, and it blew my mind, and I thought, oh man, I want to do that when I grow up. And that's beat chess grandmasters. And they did that. IBM, Deep Blue, 1997. And we also think of self-driving cars, which are new and are available, but do have a lot of ethical, legal impacts, considerations right now, although they are, generally speaking, better than people driving. I was able to take a self-driving cab, a Waymo, when I was visiting Arizona recently. It's cool in a straight line and absolutely terrifying the first time it takes a corner. And you got to sit in the back, and but after 3-4 corners, you're like, hey, this guy can drive, not bad, cool. And they're like always running the speed limit as soon as they can. So they're just like getting ready to 50 or 60 or whatever the speed limit is down there on those big straight roads in Arizona. But the self-driving cars have been around for 20 years now with the DARPA Grand Challenge. In the second edition in 2005, 5 of the 23 vehicles were able to complete it. And this was not, go do an Uber Eats order. This was drive 212 kilometers through the desert in California. So this was real heavy-duty off-roading stuff. It was by DARPA, who it's the kind of U.S. government military research branch that also invented the internet. It used to be called the DARPANet. So of course this thing is so you can get autonomous vehicles in the desert for whatever reason they may want to do with that. But point being, these have been around for a very long time. And as we continue our history lesson to get back into the client-server model and the IBM mainframe, where is it now? It's called Lenovo ISG. I work for them. And more on that in a bit. But back then, in the IBM PC, or computers, personal computers as we knew it, the market share was wild. Look at this in the early 80s. Anyone's game. Anybody can win. There's no clear winner. But ultimately, IBM and the PC and the clones eventually won. We now call it the Wintel platform, the x86, which is the exact same platform we use today. You can still buy a motherboard with ISA slots that can support cards that were designed for that system 40-some years ago, because they still work in many cases. And what's interesting here is that, IBM, big, huge market share, we're a known brand, they dominated the market. But they didn't do that alone, they did it through clones. And clones was a standard architecture. Instead of having everything proprietary, they said, let's open this up. Let's call it the AT platform, and the clones were born. Something else cool was happening in the mid-'80s. And that was these machines. And they could display one type of text. It was called UTF-8. Otherwise known as Western text. The stuff we speak, and Cyrillic, and I think there's Turkish letters and stuff in there too, but generally speaking, if you lived in the West, or the Northern Hemisphere for the most part, you could use one of these computers, no problem. And when they came out, a lot of cultures adapted to them. As we provide technology to people, it opens up new outcomes, new capabilities, new ways to communicate. And one region in particular I thought was interesting, who had a civil war happening and a large diaspora moving to the West, and that was in Lebanon, where they were able to kind of westernize the Arabic script this way. So for email, text communication, and this is the UN Declaration of Human Rights in Lebanese Arabic. I know they use the numbers to represent sounds that we can't. No, I can't speak anyways, Ronnie, maybe you can, but I definitely can. So this is humans adapting to the available technology for outcomes, and more history lesson stuff. Same thing else was going on in the mid-'80s, and that was the rapid urbanization, industrialization of China, which, if you didn't know, Lenovo is a Chinese company. Our corporate structure, our data center, it's complicated, but point being, yes, it's a Chinese company, we don't hide that. But in the mid-'80s in China, massive increase in their way of life. And they kind of had the first 3 industrial revolutions in the span of 40 years following World War II, going from a highly agrarian society to one with tractors and telephones and refrigerators and antibiotics and those things came a bit later, but they really grabbed on to it. They were like, hey, this modernization thing ain't so bad. So between the year 1980 and 2005, they basically built a new Longueuil. For those who don't know, Montreal history lesson, Longueuil is the suburb just across the river from here. So if ever you visit the Formula 1 racetrack or La Ronde, or you're in a high enough building here, you look across one of the very big, beautiful bridges, that's Longueuil on the other side. Also Montreal, fun fact, a mullet in Quebec French is called a coupe Longueuil, which translates to a Longueuil haircut. So, now Longueuil is, for those who don't know, Longueuil is about the size of Windsor, Ontario, or Green Bay, Wisconsin, or Buffalo, New York. It is not a small place. And they built a new one of those every single week for 25 years. So think how many people that is moving to the cities. And when you move to the city, you probably use a computer. You probably have a telephone. You probably have a refrigerator. So here we are. 1984, Beijing. Not much to look at. But this was the birthplace of Lenovo. And it followed that hallowed formula of all great tech companies, 2 dudes in a shed. Be it Atari or Cisco, Hewlett and Packard, you name it, Apple, of course, the Steves, 2 dudes in the shed. I think some of the greatest things in tech were conceived by 2 people in a shed, myself included. And the one big problem with those computers I mentioned is that they only displayed Western text. And if you live in the West, that's great. If you live in Lebanon, cool, someone figured it out for you. But the problem is, Chinese language, extremely different in the way it is written and read, and it just didn't correspond with the systems. And the problem was, if you wanted to display Chinese text in any way, shape, or form, it took a whole lot of emulation. It took almost half your resources, which were very limited back then. We're talking like less than 1 meg of RAM to display those texts. And so you basically have the capability of your computer just by it displaying your local language. And you don't want to do that. So a product was born, and by Lenovo, by the way, it's their first product. It was called the Han card, or the Chinese character card, which was an add-on. It was an accelerator. Much like we're doing today by augmenting standard x86 hardware by adding accelerators, be it an NVIDIA, Tesla, Intel Gaudi, whatever it may be. It is adding this card that does one thing and one thing very well, and that could be inferencing, it could be deep learning, or in this case, displaying Chinese characters. And that's why they went from being just a manufacturer of Han cards to being a regional PC brand. In the mid-2000s, I think Lenovo became a household name, or at least an industry-known name, with the acquisition of IBM PCs. 10 years later, became #1 PC manufacturer worldwide. 2014, they purchased or acquired the IBM server division, and a few other product lines that went with it, and of course the Motorola handset division from Google. The IBM server one was huge. It was all over the news, a lot of regulatory approvals, about 8 years of constant audits from the US government, 3-letter agencies. And it got Motorola too, and it was like little footnote in the news. But Moto is a huge brand. They're not terribly popular in North America. We did launch a ThinkPhone, a lot of cool PC-like features on those. But in the developing world where most people live, this is typically their only computer, and it's their mobile device, and that's where we're king. So I believe it's number 3 market share worldwide now in terms of PCs, in terms of mobile phones, which is how we now have that entire pocket to cloud. And I mean cloud very specifically, I'll tell you in a second, our portfolio. It's huge. We sell kind of everything. We're in different divisions, of course, with strengths and weaknesses in different places, and that is one for another one. Talk to Benoit. He is he's your channel guy for ISG, or Lenovo Data Center over at Quadbridge. But we also make servers. It's super important to let you know that Lenovo makes servers. Lenovo makes servers, Lenovo makes servers, Lenovo makes servers. I've said it enough times, hopefully it sinks in. They're pretty good too. I'll get to some specs in a second, but Lenovo does make servers, and it's not just making hardware like everyone else. We also have platforms designed to work with the hybrid cloud providers. So we have systems built for VMware, for Nutanix, for Microsoft, be it Azure Stack Hub or HCI, built in conjunction with them, separate firmware tracks, yada, yada, yada. We also have a storage alliance with NetApp. It's Lenovo NetApp, all one word, lenovonetapp.com. If you go to enough Lenovo trainings, you realize that we are absolutely awful at naming things. The point being, we do have a whole data center division. And of course, our newest line of products, which is called ThinkEdge, which are these guys. And here's one with the banana for scale, but do know that they do fit in my pants. So they're not big. And we got a whole whack of them over at our trade show booth, which hopefully you'll be checking out at some point this week. So what do you do when you make servers and you think you're pretty good at it? We take it to the racetrack. Luckily, people know who the heck Lenovo is now, that we're on NHL helmets, on NHL boards, and at every F1 race in big letters. And we take it pretty seriously because, as I mentioned, we don't do our own hyper-convergent software. We don't have our own storage platform necessarily, but we do have as great servers, and we take it very seriously, which is why we take you to the racetrack and we win all the time. We have 6 times more world records in the different classes. 2 CPU, 1 GPU, running XYZ benchmark. We have 6 more than our closest competitor, and we're adding more all the time. A new racetrack opens up, a new class of racing opens up. We go build a car, we do it. It also means we have the most reliable servers out there. 9 years running, independent study. It's hosted on some of our competitors' websites as well. Most reliable x86 server brand, and this is all part of the IBM heritage. 9 years of running, and a good chance we'll be doing it again pretty soon. And we are the #1 vendor of supercomputers in the world. Not a lot of people know this. We're really good at making fast machines. In fact, the fastest computer in Canada is a Lenovo. The second fastest computer is Lenovo. No one cares who wins 3rd place. And we also make the world's greenest supercomputer. And that's the least amount of watts and heat generated per flop, or whatever the metric may be. That's the Flatiron Institute. Those of you familiar with that really, really skinny building in Manhattan that's famous. They sell those big colored posters at IKEA. It's there. So we're pretty proud of that. And not only do we build, the fastest computers, we also build the most beautiful ones in the world. This is a Martin Ostrom supercomputer at the Barcelona Supercomputing Institute. It's on Google Earth and Google Street View. If you want to walk around, they've gone through the aisles, and they have some of the trays out, and you can go and click in and see it. It's all pretty cool. But it's not just making them good and fast and reliable, which we're proud of. We have a lot of big marquee customers in Canada and across the world. For instance, one fast food chain I'm not allowed to make mention. But because we do build at such scale, and we do own all of our own production facilities, we build on design for the major cloud providers. We bend the metal, we print the circuit boards, we paint the plastic. So if you sent an email today or bought something from a site named after a forest or a river, there's a good chance that you used a Lenovo without even knowing it. So again, we do a lot of this stuff. Now, out of the Lenovo stuff necessarily, it's getting into the other aspect of edge computing, and that's in the supercomputing, or I guess just the general high performance computing, that is heat. These new machines get really, really hot. The next generation of NVIDIA GPU coming out for the data center, these are the ones that power ChatGPT and power Copilot. They're a kilowatt each. That's like 2 big burners on your stove running. But this thing is about the size of a Triscuit cracker on the GPUs. So they get really hot. So one loaded rack of servers today produces as much heat as about 9 ovens when they're on full self-clean mode. Really, really, really hot. So it's how do we mitigate that heat? And the reason I bring it up is that I don't know if anyone here is buying a liquid-cooled supercomputer. If you are, let us know. But the point is that location matters. And hardware ultimately matters. A lot of the stuff we say it's a commodity item, it's just hardware, it's just servers. But as we advance technologies, we're adding servers in places they couldn't go before. When we're converting, all telco equipment from kind of things built by the Nokias of the world and converting those to virtualized, network function systems using regular servers, they got to be able to take a punch. They got to go work in those 2 post telco racks. They have to work in those little unmonitored central offices. In fact, that product was born of a very large-scale 5G deployment, where you had 2 of those acting as the complete controller, virtualizer, redundant everything for a 5G deployment. You plug that thing into an antenna with an amplifier, you're good to go. No more specific equipment, all based on x86 hardware. So hardware does matter. And we take it very seriously, especially in a high-performance space. And just like in Formula 1 or MotoGP, the things you learn in racing, you bring down to the mainstream. Paddle shifters, automated gearboxes, self-leveling suspension, turbocharged engines. All of these things were born out of racing, and now they're available in like a Kia Seltos. Happens there, eventually trickles down to the mainstream, and the next thing we're going to be seeing is liquid cooling. We call our Neptune line. This photo was taken at DreamWorks. If anyone's seen a Shrek or a Kung Fu Panda movie, it was rendered and built on one of these. If ever you get the chance to go visit DreamWorks, we have a partnership with them to go check it out. Really cool place, very quiet data center. Doesn't sound like you're inside a jet engine when you're visiting because it's all liquid cooled. Because when it comes to cooling systems in the future, you got 3 options. You can make them taller, more air going through, that works, kills your density, because you have to make the machines bigger, racks only get so big. You don't want to do that. Can't make them wider because, well, the racks are racks and it's an industry standard. You don't want to mess with that. Some of the major HPC and hyperscalers do, in fact, make a wider rack to accommodate that. But generally speaking, that's not what you want. Choose your 3rd option, which is water. So we now have a complete line of liquid cooling available for your air-cooled data center. Retrofits at the rack level, at the server level, kind of the blade enclosure level. Well, we got them all. So the reason I bring this up is that location matters. Lenovo, we take location and reliability pretty seriously, which is fine. A whole lot of Lenovo in space. So you're floating out there. I mean, good luck getting a technician. Good luck getting a spare hard drive or something, or a fan. So I'm sure they've got extras. I don't think they're just running like that. I'm sure they thought about it. But you're gonna have any vendor. You're NASA. You're the ESA. But they chose Lenovo. I wonder why. So as we go into edge computing, we talk about the unique requirements, right? And a big one is environmental. It's the wide temperature ranges. These are designed to work in places that are not data centers. Data centers typically have very controlled climate, temperature, humidity, dust levels, etc. We mitigate those. We have cleanable dust filters, just like you have on a projector. So these can run in dusty environments, especially in production facilities. They can run up to, this one is 55 Celsius. We have ones that go even higher. We've got a lot of fanless models, dust covers, etc. For ports, some with no ventilation at all. Again, you can see some of those, but the point is we've got a whole slew of solutions for those. When it comes to security too, as the Mission Impossible theme today, they offer the same level of security you expect on a laptop or any other kind of server, but they just need physical security aspects to it. One of them is the ability to brick the system for transit. So when you're staging this and setting this up, you get it all good to go. You shut it down. It cannot be turned on. You can plug power into it. All it does is power a little controller, which has to be authenticated. So this cannot be intercepted. It cannot be messed with while it's in transit. Also, when it's installed, one of these can be anywhere from $3,000 to $10,000, and maybe you want to steal it. Maybe you hate your boss. Maybe you're just a complete degenerate working at a facility somewhere, and you're like, I'm going to steal that and sell it. Well, here's the thing. You can set this up so if it detects that it's been moved, if it's left a GPS fence, if the lid has been taken off, if something has been unplugged, it'll brick itself. This message will self-destruct. You can get it back, of course, but point being, we built that kind of stuff in. So, there's that. We've yet to release the Motorola Shoe Phone. It'll be the Agent 99 Special. That's coming up. I'll let them know that's requested. But there's also continuity, right? So you don't always have good connectivity. In a data center, you often have redundant 10, 25, 100 gig lines. But at the edge, you don't. You have Ethernet going into a local network. We also built in cellular as well as Wi-Fi connectivity onto those. So if one connection goes down, you've got some redundancy there. Perhaps you're being installed a facility that just doesn't have good internet. It's out in the country at a meatpacking plant or something like that. Maybe only have like maybe a 1 gig, maybe a 10 meg connection out there. So you want to have multiple options. And finally, there's the management aspect of it too. These are managed like any other endpoint, be it on the PC side through a vPro type connection, or on our more server type machines. We do have your typical remote management, what you'd expect from an Xclarity or an ILO or an iDRAC, as well as some deployment tools. I saw the deployment was one of the pain points that was mentioned earlier. I do want to address that in just a second. Doing on time. Did not start that stopwatch. All right. We have an whole edge portfolio. I'm not getting into the part numbers like I mentioned, but we do come from AMD, Intel, NVIDIA. The NVIDIA one's pretty cool. That runs an NVIDIA Jetson microcontroller, but beefed up for enterprise. So you have your on-site warranty, your global availability, your uniform model, tech support, on-site 4-hour service, those types of things. You can think of it as world's fanciest Raspberry Pi. These support real GPUs. Everything from your A2 and your T4 in that class up to your big A100s in our larger models. They have the server level RAS, so reliability, serviceability, etc. And they also come with industrial connectivity. These aren't just servers we put in a different box. We've also integrated microcontrollers, CAN bus controllers, multiple serial ports, multiple parallel ports into them, often through breakout cables, because we realize these are going to have to interface with other machines that aren't necessarily IT-based. A production, an assembly line, for instance, you want to shut it down. That could be as simple as tripping a pin from 0 to a 1, or it could be through a CAN bus connection where you can actually send it, a code and work through an API to shut things down, or slow it down, for instance. So you've got all that connectivity built into it, the Wi-Fi and the cellular, the enhanced security, as I mentioned, it will self-destruct, these ruggedized designs, global support, and a whole bunch of automated deployment, which I'll touch on in a second, and again, it's available through QuadBridge. What we want to do is take all of these niche devices and convert them all into a standard architecture. And that's how everything is going. Everything goes through our phones now, everything goes through a PC. And we'll look at some trends in just a second. And that is consolidation. It is taking formerly disparate workloads, different workflows, different machines, different platforms, and converted those all down into a single one, and those are running an IP and code that is running on x86. Be that bare metal, containerized, you name it. It is all happening on a regular old hardware. It's pretty cool, it's got all that special stuff, but it's still regular hardware at the end of the day in terms of how it's managed by IT. And then we've been able to consolidate all of that data is to accelerate it. So some real world examples here. We think of this. All of these devices by Sony 1985 catalog have now been replaced by your phone. And this has been, I think, a thing in presentations for 10 years now. But so new ones recently. I now use to pay everything. A lot of point of sale systems are now just a phone with a printer on it. I have my Nexus card for travel on here. I don't have a passport. I always bring one, but beep, I'm in the country. Don't let them in. There's a lot of stuff you can now do with your phone, and it's been talked about a lot. But it's when you get that information, instead of just doing one task, it's how can you mix those together. And I think a great example is this application here called Aopoly, and that's for blind people. So it's one thing to take your phone and be like, where am I? You're in a conference room, you're on stage, you're naked, it's a nightmare, you don't have teeth. But it's not just what are they, you can ask them questions about, when's the next bus coming? How do I get there? You're at a restaurant, what's on the menu? What can I afford? What's healthy? And as it learns who you are, it can then alter that AI model, it can pull pre-trained models, it can pull your data down from the cloud, when there's the appropriate connections available, to provide this personalized experience in this application. I think we all know a personalized experience, be it through Netflix, through Spotify, through Amazon Shopping, but this is the real life. So if you can integrate this, it can learn who you are, it can alter that model, it can fine-tune it, it can help others that may live in the same situation, going through the same things as you. It can process language, you can talk to it, it can provide you answers in a way you understand, the way you want to live. This is solving a real problem for people. It's all being done through edge computing because so much of this horsepower, of that image recognition, of the translation, of speaking, the text-to-speech, speech-to-text, all these capabilities have to be put in here. Otherwise, you are doing gigs and gigs and gigs back and forth to the cloud, which is going to be expensive, it's going to be slow, and it won't always be available. So putting the power in here is what it's all about. So this is the AI integration, virtualization of legacy systems. That's a big aspect of this. A lot of that is putting AI on video surveillance systems to provide more insights, to detect things, be it for safety, security, customer experience. We're now also seeing demand-based pricing and service levels. And this could be things as simple as, oh hey, there's a bunch of people leaving a hockey game. We should send more buses. Now I know the STM and the teams work together for the shuttles, etc., but it's impromptu events or maybe unpredictable demand, based on weather. Hey, it's a really nice day out. There's more people out at night. Maybe we should do more buses. Maybe the taxi company should dispatch more people. Again, these are all things that people have been doing forever. It's supply and demand. It's economics. It's ancient. But we can automate all this and really fine-tune it to reduce waste and up the service levels or things we're doing. Facilities automation, security, video surveillance, entry, exit, forecasting and long-term analysis based on what people are doing, what they're wearing, what they're saying. Is our product any good? We don't have to wait for one review, but if you can analyze social media, if you could look at all of Facebook, all of Twitter, and all of Reddit, what is public, to say what are people saying about me, what's hot, what's going to be cool, what should we be buying more of, where should we secure the contract for a component, or a designer, or a label, or a musician, whatever it may be. What's hot, what's going to be cool, using AI to do that, and also with some edge functionality. Of course, live translation happening in real time with chatbots. I'm sure there's systems out there right now. Look at the UN, for instance. Instead of having one person translating every language, you can do that all through AI. It's pretty cool. And predictive maintenance. Then today, we're about consolidating disparate data sources to deliver outcomes. We're trying to solve problems. And the thing is, they're not necessarily driven by IT. I saw the list of attendees. Almost everyone here is IT manager, IT director. Very important jobs. And ultimately, you'll be managing a lot of these things once they get put on your network or they're managed like an endpoint. But the point being is that these are not necessarily IT-driven decisions. These come out of security, asset management, they come out of talent acquisition, they come out of security, manufacturing, quality control, things that are not necessarily IT, but that's what's driving them, and this is where we're seeing the biggest uptake. Our most successful POCs and things rolling out are driven by those other workloads in the company. The one thing that was IT, we mentioned staging and deployment being slow. This is a typical activation and deployment. You get it, you build it, you image it, you ship it somewhere else, it gets deployed, you've got smart hands on site to set it up, plug it into your network, a lot of steps. I know that QuadBridge and their integration partners can assist with a lot of this, and not to say that this is happening for a very long time. I'm sure you're all familiar with things like this. It's just that it takes time and money. And we're talking about the edge. We're deploying these at dozens, if not hundreds of locations, and it can be very cost prohibitive to send one of your high-paid technicians to go do the work. When really all they need is electricity and an Ethernet cable, which is why we've automated that through a software called Lenovo Open Cloud Automation. It's LOCA. They insist on calling it Lock-A. I think they're really missing out on that. The point being is we've developed a system where you can send a completely virgin, unimaged, unmanaged unit out to any location, plug it in, it'll say, hey, where am I? What's going on? It'll ping into home base, and it will be imaged. It'll have the correct IPs, user accesses, and all that assigned to it, licensed, ready to go, much shorter deployment time. So we're also addressing some of the IT things there. Another thing I wanted to mention too, may not resonate as much, no, not everyone here is from Quebec, but our two leaders in the edge space at the global level, Charles Ferland, based here, was an NDG, and also Benoit Robert, who recently retired. He's still on as a consultant, but he is the manager of the overall portfolio and where we do, what we build, and who we partner with. So this is a local product. Local meaning literally Montreal, which is kind of fun. Again, we're using technology to solve problems that could be solved by people. That's the big difference. Every example I'm going to show here could be done by hand. However, we're automating as much as possible. We're augmenting the ability of people to solve challenges, to make systems run smoother, safer, more healthy, and in a few cases we're going to see here, at the kind of global environmental level. So the first one I'm going to mention was a steel facility in northern Alberta. And they take old shopping carts and I-beams and crushed cars, and they turn them into new I-beams and new cars. Mostly post-consumer steel. One problem though. Propane tanks. You got to watch out for them. Because if you take that propane tank, pick it up with that big claw arm, you're not paying attention, put it in the smelter, put it in the shredder, there's a good chance it's going to go BAM! Which you don't really want to have happen. Because it hurts people and damages equipment and shuts down your assembly lines. And you might, have to deal with these people. Another Quebec joke, this is OSHA, or Workman's Comp in Quebec, and workplace safety investigations. You don't want to deal with those guys. So we developed the system using kind of a pre-trained model in Azure Cognitive Services in the cloud, but then added the specific items which are dangerous to that facility. In this case, it was propane tanks. Not just the barbecue ones that people are familiar with, but the larger ones used for welding and heating facilities. And training on that, and then integrating that into the system so the operator of the crane could be alerted like, hey, there's propane tanks here, 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 watch out for those, and then dispatch someone to go pick them up. Or if they do pick one up, say like, whoa, 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 put that down, don't do it. And if they get too close to the machine, it can shut it down. Big red button gets hit, through the serial port on there, and shuts it down. Saves people's lives, saves equipment. Now, I don't know if anyone here operates a steel recycling facility, but the point is, these systems already exist. And if this is looking for a vehicle that's not in the right place, looking for quality control, there's something there that shouldn't be there, or is something missing that should be there. Should someone have a hard hat on, a yellow vest, a mask when COVID was big? That was something we talked about a lot. These can be easily transposed. These systems already exist. And this is one way we're using it in a remote, rugged, harsh environment where you could do this with people. That's a whole lot of people. They're fallible. They get tired. You got to pay them every hour. As where this doesn't have those issues. Another thing we're doing is in fishing. As you know, in fishing, you're only supposed to catch one type of fish. And in many cases, they do the sorting and the processing on the boat itself, which is cool. So they can go out, they can catch the fish, look at them, and someone goes, too big, too small, wrong fish, send it back, hopefully it's still alive. Again, you're doing it with people, but not everyone's perfect. And the more wrong stuff you catch, well, you killed an animal for no reason, you're hurting the environment, you can't sell it, and in many cases you'll get fined. You don't want to deal with these guys, could get in trouble. To sell a whole lot of fish to pay these fines for fishing fines. This is true in your personal fishing life and also in industrial, which is why we created a system. Now, for the keen-eyed viewer out there, you may see that there is a dolphin, a baby beluga, and a mermaid in there. Things you're not supposed to be catching. So same story, develop a system where we could look at those and alert people to say, like, hey, put that back, don't catch that, put it back. Ask the mermaid, what's the mermaid's secret power? Will she marry you? I don't know. Ship it back. And again, it's saving environment, it's dealing with regulatory controls, and ultimately being able to sell everything you catch. Every pound you bring in, you want to turn into money. If you're bringing back fish you can't sell, that's useless. That's waste of time, fuel, and cargo capacity. But if we take this even further, is if we can analyze all of our catches and figure out where's a good place to fish, where's a bad place to fish, and then you can create a model with that to figure out, we know this time last year, this was the section to go fishing. And I know there's already a lot of people doing research on this. If we can get more and more and more data gathered that's generated on these ships and compile that, we can figure out a better understanding of the species, their migration patterns, to create sustainable and ecologically friendly and long-term fishing practices. Which, again, those researchers doing that, fishing and catching them, and probably hiding the stuff they weren't supposed to catch. So it's consolidating that, and it's all because we now have the technology that's powerful enough directly on the boat. A boat is not a data center. Another fun one, these are all about animal processing. I guess I'm always hungry when I do these. It's in factory farms. When we have all these pigs here, there's thousands of them, they all kind of look the same. I was shocked this is not the same pig. They got the same face. I guess they're related. But when you look, it's very hard to look at the health of all of these animals. And the one thing is, if one animal gets sick, they can all get sick, and you're forced by law to cull the herd. Thing is, it's really hard to go look at them all, to check their temperature. Can you imagine going around and checking all their temperature? It's hard enough to get one thermometer in a child's mouth, let alone thousands of pigs. And any parent will tell you that your kid is sick by how they act. It's not just, are they sneezing? Are they blowing their nose a lot? It's, are they sleeping too much? Are they tired? Are they lethargic? Are they eating enough, drinking enough? Which is why a company called Circuit was able to deploy on the SC350 real-time analysis using cameras of pig behavior. And you can see how often they walk, they eat, they play, etc. And you have a pretty good idea what a healthy pig looks like. A sick pig will not act like that. And then you can go address that one sick pig. Are they hurt? Are there something wrong with them? Can you treat them? Is it a virus? Is it antibiotics? And then just treat that one animal as opposed to just spraying them all with medicine, because that leads to antibiotic resistance, which is a terrible thing, not only for the pigs, for the farm, but also humanity, as we were so reliant on these at keeping ourselves safe. Antibiotic resistance, of course, becoming an issue in hospitals, care facilities, etc. So to combat that, we're using AI, which ultimately needs that horsepower to analyze that many moving animals without taking the video feeds and sending them off to a data center, which does not exist at a farm, does exist in the cloud, but it's going to be slow and expensive to use it. So putting the power out there. Another one near and dear to our hearts here, and our wallets, are potholes. This is in Bruce County, Ontario. Same thing. We put cameras on trucks to identify potholes. And it's not just looking for the pothole, that's one thing. We've got multiple cameras on city vehicles, and they're not out looking for the potholes. These are vehicles that are doing electrical work, garbage pickup, police cars, etc. So they are passively going collecting all of this data. We're using high-resolution cameras, and we could take those camera feeds, store them on a server, pull the hard drives out, put them in a server in a data center, run the analysis, figure out what the 10, 20 potholes are, put those in the GIS system, put the tape or the hard drive back. It's a lot of work. But all you really want to know is, where's the potholes, what do they look like? So these things are zooming along, and they're constantly taking video, but it just erases it all. Most of the data that's collected is useless. What you want to know is where the potholes, what do they look like? You compile that into your GIS system. You can see where they are. You can dispatch crews, long-term planning for roadworks. And if you start seeing that one contract that built your roads 5 years ago are failing at a rate much faster, there could be penalties that could be paid. You could not use that contractor again. You could use a different type of bitumen, etc. So it's how do we take this data for long-term analysis, but also identify problems right now without paying a bunch of students to go sit around in cars and drive and note down potholes? Because again, could be solved by people, but isn't. Last but not least, second last is AI loss prevention. We're doing this at Kroger. It is using machine vision in real time to identify people that are trying to cheat the system at self-checkout counters. I know it's annoying to place the last item back in the bag. But when your store is being robbed $500,000 a year, and you've got 700 stores in the US, you can imagine how much money that is. So with Everseen, who's one of our software vendors, we put these in every Kroger store. ROI was achieved within 4 months. They rolled it out at large scale much faster than predicted. Sorry for the vegans in the room, but this is one of my personal favorites. And that is meat production, AI, and edge computing in a slaughterhouse, or an abattoir, or processing facility. And the meat on the animal is either cut into steaks for human consumption and sold at a very high price per gram, or turned into hamburger, or hot dogs, or dog food, and whatever comes next. You want to get the highest amount of high-value meats out of every cut. Thing is, you've got people processing all of these. And you want to make sure you cut more porterhouses than T-bones than you do hot dogs. But the plant workers are paid by the hour, and as long as they're doing a good enough job, our customer in this case, they didn't really care. You know, I'm doing a good enough job, that's all I got to do. I'm not getting paid anymore. It's not like I want to be, CEO slaughterhouse. It's a job, right? But what if you can incentivize your workers to do a better job by gamifying the experience? And this is exactly what they've done. This is called white bone analysis. And it uses AI in real time to look for how good the cuts are and providing them with incentives and bonuses. So we want to gamify the experience of your workers. So if quality control is an issue and you know that 2 employees, one could have a better yield or a better product than the other, how do you incentivize that other than just long-term, you're doing a good job, you get a bonus? What if we were able to do it in real time? You hit a certain percentage every day, you get an incentive, you get a bonus, you get the trips, you get the Starbucks card, whatever it may be. So you want to make it fun, you want to gamify. That's one aspect we're able to do with AI. And because you want to provide those slaughterhouse employees with bonus points. Yeah. Thing is, AI is everywhere. My dad is 77. He's always telling me about stuff he saw on the news. These are all from mainstream news sources. Suicide prevention in the metro, that's a couple months old, that's kind of fun. Or adding AI to the road cameras, which are typically used for traffic violations and speeding, are now catching littering. It's about updating that model. Did something leave the vehicle? And were they driving too fast? Who are they and can we find them? Littering's bad. If we can catch them, so be it. Yes, it's Big Brother, but it's also Mother Earth, so we have to balance that. AI supercar, that's kind of fun. The Baby app, which I think is cool. I think Homer Simpson came up with that about 25 years ago. And of course, there are some sad stories like deep fakes of Elon Musk telling him to invest in a fake crypto thing. So to bring it back to earlier on, no one does this stuff alone. Every solution needs partnerships. It needs multiple people working on it at once. We can't do it alone. Lenovo can't do it alone. We know that. NVIDIA can't do it alone. Intel can't do it alone. No one can, which is why we've come up with the AI Innovators Program. And although these are very established brands, I'm sure everyone is familiar with and using, there are approximately 8 bajillion AI startups out there. And a lot of them won't make it to the end of the year. And some will merge, be acquired, or sold off. But there's a lot out there, and no one knows who's good. So we've gone out worldwide as a scouting effort, much like you do in pro sports, and we're trying to figure out who's real, who has the potential to become a big brand, and working with them and providing them with investment and our expertise and our facilities, providing them with demo equipment, and working with them so that we have a vetted, tried and tested solution, take a lot of the guesswork and a lot of the risk out of working with some of these smaller players that provide niche applications in the world of AI. So that's the AI Innovators Program. We now have 165 solutions across our portfolio, everything from large data center down to interesting things we're doing at the edge. And that's something we take very seriously. We can't do everything by ourselves at Lenovo. We have to work with all these brands to build almost every single system is going to have one of these, if not multiple components in it. And the good news is, we only work with partners. We want to work with our partners, which is why we've got QuadBridge. You can tie it all together to make that solution happen. Solving your business problems that could be solved by people. So to wrap it up, 2 last slides. That we're putting AI everywhere these days. And the 2 big things, I know that Lenovo's best known for their PCs. We have AI PCs. This is a new standard. If you hit 40 tops on your laptop, so it's a certain benchmark of performance, you call it an AI PC. These are designed to run Copilot, so kind of your local LLM and understanding and analysis of your Microsoft Office products. You can also do a lot of audio-visual processing, blur the background, take the noise out, etc. for better conference calls. Doing the same thing on mobile. Some of the onboard translation, machine vision apps, same concepts. The last thing to leave you with is kind of the sad one, is you have to, and that's the ethical and legal impacts of AI. Legislation, humanity, criminals are moving a lot faster than governments are. Technology moving so fast, which is accelerating, right? We're in this kind of hockey stick of what's happening right now. What bad actors, be it companies or governments, can do with facial recognition. It's a major concern out there. Banning people by who they are, who they voted for, just the color of their skin. Also bad actors using things like deepfake videos. They're highly convincing to trick people out of money. Kind of thing is called the nephew scam. There's a classic one, help, I'm in a different country, grandma, you gotta help me, I'm your nephew or whatever. But now doing that with very convincing audio and video, and also in understanding your voice, with more analysis, your personality, what you would say, and if they get access to your private data into your cloud, into your email, they can answer very personal questions. It's a huge risk. There's probably a lot of movies about this. And the big one is bias, I want to mention. The models that we create are only as good as the people that train them and the data that goes in. Garbage in, garbage out. And if you train a model with bad data or harmful data, it can impact and just perpetuate those stereotypes. So, for instance, this is one I did on Stable Diffusion, and I asked it for an American citizen. Apparently an American citizen is a handsome man with glasses. A white man, you may have noticed. And he likes hats, too. So if you're an American here, I expect you to look like this. AI said so. However, the exact same model, when I asked it to create portraits of American criminals, gave me this. So stark contrast there. And it's scary because if we trust more and more of our lives and our legislation and our policing and our automation, it's the bias in these models. So you've been warned. It's out there. So you got to keep these kind of things in mind. AI is not solving everything. AI is an extension of our humanity. It is fake humanity, and it has the same real problems that we do. So in conclusion, we're living through, if not driving, us as IT people, as those in the industry, driving the 4th Industrial Revolution. It's happening right now. AI systems are only as good as the people that create them and the data that goes in to create the models. All solutions, big or small, require collaboration of multiple parties working together, multiple products, multiple vendors, multiple platforms to make happen, and the little ones alliances are there to help. And we make servers, you can't forget that. Super duper important. If nothing else resonates, it's that. Today we have workshops available, we have labs available, we have POC gear. If you want to run a model, we've got the latest and greatest NVIDIA and AMD GPUs available to use kind of on a cloud basis. Remote login, use them for a couple days, work with the data scientists to get happening what you want to happen. If you get the chance, we do often have trips either through QuadBridge or open to multiple customers at once to our Raleigh, North Carolina headquarters. And also we offer the same type of visits to the DreamWorks facility, not just for those in media and entertainment, but they provide an excellent
example of how you can use technology across the artistic and the technical aspects to bring something to light, which in this case the movie, which is kind of fun. We're also going to be doing a few workshops. I'm doing one on edge computing as well as ones to save in the data center. I forget which is which. Those are happening in the next couple days. So we're talking more about the edge in one. The other is ways to address budgets, which we saw was the #1 concern. So have fun, enjoy the event. We've got a ton of gear at our booth if you want to check it out. And with that, thank you very much. Have a good day.